Hello Ace, this is RetroTK2 and today we're looking at the partial keyword in C#. If this is your first C# video, I'd strongly suggest watching the series from the start. The card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Card should be on your screen once again. So let's get started. What is the partial keyword in C#? Well, according to the Microsoft docs, it is possible to split the definition of a class or a struct, an interface or a method over two or more source files. Each source file contains a section of the type or method definition, and all parts are combined when the application is compiled. Partial classes. There are several situations when splitting a class definition is desirable. When working on large projects, spreading a class over separate files enables multiple programmers to work on it at the same time. I don't necessarily agree with this first point, Ace, because I would say if you're working on a large project, you would ideally have that source controlled, so therefore you could work on the same file at the same time and it would merge both together. So whenever it talks about splitting them across two classes into separate files, I would personally disagree with that. But hey, let's press on. When working with automatically generated source, code can be added to a class without having to recreate the source file. Visual Studio uses this approach when it creates web forms, web service wrapper code, and so on. You can create code that uses these classes without having to modify the file created by Visual Studio. To split a class definition, use the partial keyword modifier. The partial keyword indicates that other parts of the class, struct, or interface can be defined in the namespace. All the parts must use the partial keyword. All the parts must be available at compile time to form the final type. All the parts must have the same accessibility, such as public, private, and so on. If any part is declared abstract, then the whole type is considered abstract. If any part is declared sealed, then the whole type is considered sealed. If any part declares a base type, then the whole type inherits that class. All the parts that specify a base class must agree, but parts that omit a base class still inherit the base type. Parts can specify different base interfaces, and the final type implements all the interface listed by all the partial declarations. Any class, struct, or interface members declared in a partial definition are available to all the other parts. The final type is the combination of all the parts at compile time. Note the partial modifier is not available on delegate or enumeration declarations. At compile time, attributes of partial definitions are merged. We'll get into those a little later, Ace. Don't worry too much about them just now. The following are merged for all the partial type definitions: XML comments, interfaces, generic type parameter attributes, class attributes, and members. Restrictions. There are several rules to follow when you're working with partial class definitions. All partial type definitions meant to be parts of the same type must be modified with partial. The partial modifier can only appear immediately before the keywords class, struct, or interface. Nested partial types are allowed in partial type definitions. All partial type definitions meant to be part of the same type must be defined in the same assembly and the same module. For example, the .exe or .dll file. Partial definitions cannot span multiple modules. We'll get into modules and assemblies at some other point in the future, Ace. The class name and generic type parameters must match on all partial type definitions. Generic types can be partial. Each partial definition must use the same parameter names in the same order. The following keywords on a partial type definition are optional, but if present on one partial type definition, cannot conflict with the keywords specified on another partial definition for the same type. They are public, private, protected, internal, abstract, sealed, base class, the new modifier, and generic constraints. Partial methods. A partial class or struct may contain a partial method. One part of the class contains the signature of the method. An optional implementation may be defined in the same part or another part. If the implementation is not supplied, then the method and all calls to the method are removed at compile time. Partial methods enable the implementer of one part of a class to define a method, similar to an event. The implementer of the other part of the class can decide whether to implement the method or not. If the method is not implemented, then the compiler removes the method signature and all calls to the method. The calls to the method, including any results that would occur from evaluation of arguments in the calls, have no effect at runtime. Therefore, any code in the partial class can freely use a partial method, even if the implementation is not supplied. No compile time or runtime errors will result if the method is called but not implemented. Partial methods are especially useful as a way to customize generated code. They allow for a method name and signature to be reserved so that generated code can call the method, but the developer can decide whether to implement the method. Much like partial classes, partial methods enable code created by a code generator and code created by a human developer to work together without runtime costs. A partial method declaration consists of two parts, the definition and the implementation. These may be in separate parts of a partial class or in the same part. If there is no implementation declared, then the compiler optimizes away both the defining declaration and all calls to the method. Partial method declarations must begin with the contextual keyword partial, and the method must return void. Partial methods can have in or ref but not out parameters. Partial methods are implicitly private, and therefore they cannot be virtual. Partial methods cannot be extern because the presence of the body determines whether they are defining or implementing. We'll get onto the extern keyword probably another series after this is. Partial methods can have static and unsafe modifiers. Partial methods can be generic. Constraints are put on the defining partial method declaration and may optionally be repeated on the implementing one. Parameter and type parameter names do not have to be the same in the implementation declaration as in the defining one. You can make a delegate to a partial method that has been defined and implemented, but not to a partial method that has only been defined. Okay, it's a ton of information there, but let's go through it nice and slowly. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. As usual, I'm going to be using Unity Spice for all our logouts, so be sure to check out the card on your screen now if you would like to get it yourself. Okay, so partial types are defined like so. You have a public or whatever your access modifier is that you want. You type out the partial keyword and then you use whatever type keyword you want. So let's have class and we will call this partial class. Why not? Excellent. So as you can see, it's not a partial class. This will probably come up with, well, it's graying itself out here because we're not actually using it. But if I create a new copy of this, you'll see that this one becomes non-grayed out and allows us to have a split definition across both the class. So it's essentially this is going to try and merge these two together at compile time, and you will be able to use them just as you would normally do with any other class. So let's try this here now. So method 1 with a void, and then we'll do a var obj equals new partial class. Please help me. Yeah, brilliant, good. Okay, obj dot method 1. Excellent. Okay, so nothing too surprising, nothing too strange or startling there, yes. But if I do a void method 2 across here, save it. Don't necessarily need to save it, but if I go into obj dot and do, you'll see that method 2 will show up. Excellent. And really honestly, yes, that is probably about as complex as partial methods get. Now, the doc said that the best way to use partial methods was, of course, if you were working on large files, that both coders could work on the same one. I don't think I've ever seen that before. Not saying that it couldn't happen, but hey, whatever. But the most common place I've ever seen them is in Windows Forms. If you've ever used them. If you haven't used them, don't worry too much about it. But it's great whenever you have other code that's generating these classes for you, such as the Windows Forms does with its... I suppose we could actually create one. Okay, let's go and create a new project, and I'll show you exactly what the Windows Form does. So for any of you that have had the chance to actually use Windows Forms, they are pretty darn good, actually, to be honest. But let's have a look at them here. They are excellent for, I mean, pretty much, I believe the majority of projects are usually created using, I want to see the WPF app, although I honestly don't think it necessarily matters. It's just so long as you're creating it using some form of, so long as it solves the problem that you're trying to do, it doesn't really matter what you're doing this with. It doesn't really matter what how you're solving the problem, so long as the problem gets solved, let's face it. Okay, so if I click OK, and hopefully we will open up our new Windows Form app. And as you can see, we have a form here. And if I go into View and View Solution Explorer, you'll see that we have the form.cs. We also have the form designer. Now, as you can see, partial is added to this class for form 1. And in here, we have our own designers. So anything I place in here will probably be auto-generated in here, allowing us to go with that. So hang on, if I go into Properties Windows is no other. I want the toolbox. Where's the toolbox? Hey, okay, so brilliant. So if I go into toolbox, here it is, and I add in a button, hopefully it'll all be added to the designer, as you can see. And there you go. We've got the text for the button one. We've got this .text, and as you can see, this is being added to. Well, you can also go into the form.cs, and actually, if I double click on this button, you'll see it'll create a form.cs that we ourselves can go into. And in here, we can add in our code, whatever code we wanted to do. So on this button click, we could make it, say, console dot write line, I believe. And, you know, log out something, whatever we wanted to log out on that button click. But you can see how much of a pain this would be, and how much of a nightmare it would be for the coders if we had to go into here and add it in here. So if I put this into here, I'll be interested to see, yes, please import it. I will be interested to see if this doesn't get completely eradicated whenever I add in another button. So let's add in another button, save, and if we go back into here, no, it doesn't get eradicated. It still has the button one. So I suppose you could have it so that you were coming into here and editing this part here, but as you can see, we're getting it tangled in between the actual generated code and the code that we're trying to define ourselves. So it's far better just to have this stuff in here, separated out from our generated code in the actual Windows Form Designer. Now, in Unity, as far as Unity is concerned, I can't think of a time whenever you're going to have generated code from Unity. I'm not saying that it won't happen. I'm just saying that I'm trying to think of a time whenever it does happen. I honestly don't think it's ever happened to me, but that doesn't mean to say that it doesn't happen, yes. So you can also have nested partial classes as well within partial classes, yes, if you would like. You can have it like so, partial class nested. And then we will also have a partial class here, which is nested. And we will do a public void method 1, why not? And now if we go up and change this to, no, let's create a new one. Oh, for goodness sakes, let's create a new one. Object 2, excellent naming convention as always, retro.method. Partial class nested. Oh, come on. Come on. Nope. Oh, because of the partial. Okay, excellent. Yes, yes, yes. Okay. Partial obj2, and of course there's the method there. Yes. So you can have nested partial classes if you like. Yes, I would say that you should be using partial classes sparingly. Really, the only time I've ever seen them being used is with generated code, like we've seen with the Windows forms. If you're trying to separate out pieces of code into partial classes, then that's probably saying to you that you should be actually creating another class and splitting out the code into that other class so that you can separate the concerns of the class. That's probably the agile way of thinking about it. If you're using it because you have two coders that are working on the same class, then I would suggest strongly that you should be using some sort of source control system where you can merge that data in together, personally. But you're the coder, yes, you do whatever you want to do. Now say we had an interface, yes, that was, let's say, I want to say partial, but it's not necessarily a partial interface, but we shall go with it for the moment. Why not? If I was to put on a void method, and was also going to, yeah, well, I tell you what, for the sake of argument, let's create a partial interface. As you can see, we actually get an error saying duplicate definition of iPartial, possibly missing the keyword partial. So if we put in a partial keyword, we can quite nicely just get that done like so. And if we go like this, maybe I'll just do method 2, which would be fantastic. Okay, so now if I add iPartial to our nested class, you will see that both get the interface is not implemented exception, but if I go and implement the missing members, I can add them both to the same partial definition of the partial class nested, or I can split it, as I'm sure you've come to notice now that you can split the method, method 1 and method 2, and this iPartial is still inherited, and the contract still needs to be upheld even in the partial version without the inheritance declaration, which is all brilliant. Okay, brilliant. Now let's go and really hammer this point home by creating another interface. Let's just call it lol, why not? And let's have void pop for the actual method, and let's have it be declared by this one, lol. Probably should be ilol, but we will go with this for the moment. And as you can see, oops, the actual error is present across both because, of course, even though the declaration is only on this one for the lol interface, the contract has to be shared amongst both, and this one actually is implementing the lol interface as well. All fairly obvious stuff, I'm sure. Yes, I just want to really hammer this stuff home. I'm going to change this to ilol because why not? Excellent. Okay, so let's go and let's have a look at partial methods. So partial methods, as we've already known, can only be private. So if I did public partial void method A, sure, why not? You will see that we get an error saying a partial method cannot have access modifiers or the virtual abstract override new seal or external modifiers, as we've already known before. These are private methods that need to be implemented in here. So if I go in and do a void method, method A, I can go in and give this some sort of definition. So let's do a log method A dot log, and maybe method with the same signature has been declared. No, it has not. I need to put in partial, of course, partial, and there we go. So you could definitely see this being used in some sort of way, yes, and you could definitely see this being used, yes. So let's have this public, and let's call it now then. Let's have the log method being called here. Whoops. Let's have method A being called here. And that should be all brilliant. So you can see how this actual thing works. It's all pretty basic. And this would be sort of useful if you were using it. This would be sort of useful if you were using it for the auto-generated code. So say we had some sort of Windows form thing that was generating this code for us. We could tap into this partial method, have this being called in this aspect of the actual class in the auto-generated part, maybe here, so that the log would just call method A and nothing would come of it. So if we actually called into log, method A wouldn't be implemented here, and therefore this would just be cancelled out, eliminating the overhead of the actual virtual call, which is kind of nice, I suppose. So if I go into here, just to hammer it across, drag our script onto any game object in this scene whenever it's recompiled, and play the game, you'll see that log method A is of course called because it has been implemented. Excellent. And the main thing to note with the partial method call is that you cannot have a return type from it. It has to be a void. So method return value is never used. Partial methods must have a void return type. I think that'll do, yes. I think that's been a pretty extensive look at the partial keyword. So yeah, Rate, comment, subscribe. Yes, I hope you're enjoying this C# series. I'm enjoying making it. It's just been a while since I've done the last one, but yeah, it's cool. You can email me at retrotk2@gmail.com with any problems that you're having with C#. Thank you for watching this, and I'll see you in the next video.